Hello everyone, welcome to this fresh session on switching theory and logic design. Myself Dr. Sohail Rana. We are studying Boolean algebra. Today we will see few important examples using universal gates and converting of AOI logic to NAND and NOR logic examples. So let us begin with our today's session. So what we are talking about is converting some logic to NAND or NOR gate. So first stage what we have to do is to convert the all the outputs of each AND gate with inverter. That is, we will add one bubble. Suppose any AND gate is there. So first we will add one bubble at the end, and if OR is there, so at the input we will add bubbles in the given circuit, and wherever we add bubble, that inverter there will convert attach one inverter to that gate, and finally we will replace this inverters and the bubble inverters with NAND gate. So OR gates, bubble NOR gates and inverters will be converted to NAND gate finally. So let us see directly one example so that we'll understand it in more detail. Say the example is convert the following AOI logic circuit to NAND logic and then NOR logic. So let us do this task. So given circuit we will see. Say we have one AND gate here where A and B are the inputs. This output of this AND gate, and another one OR gate is given where C and D are the inputs. Both of them, their output is given to one AND gate followed by one inverter, and this inverter is again one of the input for next OR, along with one line coming from A and attaching to this OR gate. So this circuit we have to convert to NAND and then NOR. So let us see this. So now in big canvas we can see that. So say this one we have to convert into complete NAND. So what we will do here, first stage we will put bubble at the end of all AND gates and at the beginning of OR gates. So here we have first AND gate. So at the end of AND gate we'll put bubble, this input as it is. Then at the input of OR gate we will add bubble. So this is OR gate. On this OR gate input we will add bubbles. Okay, and then we will connect it to next AND gate. For this also we have to add one bubble. Then this inverter will be as it is, and this inverter is giving input along with this A to this OR gate. So at the input of OR gate also we have to give bubbles. Now this is first stage. Now second stage, what we have to do, wherever bubble is received, there we have to connect one inverter. So here we will start with this one, this AND gate, one bubble is attached. So after this we have to add one inverter. Then before the OR gate there are two bubbles, so here we have to add two inverters. So this A and this is B. For C we'll attach one bubble. For D we will attach second bubble, and these are connected to this bubbled OR gate. So this is bubbled OR gate. So this will go to next stage. Next stage is AND gate. Now at the end of AND gate already we have one inverter. So this AND gate already we have one bubble and there is one inverter connected there. So that is also for the input of next bubbled OR gate. Okay, so here also one bubble is there. For this one, in between this path we have to connect one inverter. So these all inverters we have connected. So say A, B, C, D. Here we can say this is G, this is H, like that. Now last stage is to replace all bubbled OR gates and NOT gates by NAND gates. So whatever is there other than the NAND gate, we will convert them to NAND gate. So this will go NAND gate, this will be NAND gate, and this one also we will convert as NAND gate and redraw it. So everywhere we will get NAND gate. So let us redraw this one. First we have this NAND gate. Now this NAND gate is connected. So this is A and B. This is going like this. So here we have one inverter. So there also will connect one NAND gate, single wire. So we'll connect, give same input to both the inputs of NAND gate. Now output of this is connected with one AND gate. So this is also converted into one NAND gate. Now this output is connected to this one. So this will connect here. Now output of this one is connected with this inverter. So this one will become again NAND gate. So here we will connect one more NAND gate. These are all inputs for the. Now this one also will convert as NAND gate. Now here C and D is remaining. So C and D, here C and D we are connecting with. So here we'll connect C and D there with inverter. So say it will be C bar, D bar. That this OR will convert to NAND gate, and this one we will connect with this input. So this will be the equivalent circuit using NAND gate. Now similarly this one we can convert to NOR logic. So let us see how to convert to the NOR logic. So here we will draw the same circuit again, and so here we will draw the same circuit and we will see how to make the NOR logic. Say the AOI circuit we have to now solve for NOR logic. Everything should be NOR at the output. So what is the given circuit? First stage, that we will put circle at the output of each OR gate, and this time we will make AND gates, bubbled AND gates. First input is say A and B to AND, so we will make it bubbled AND. So output of this is also connected to one AND gate, that also will make bubbled AND gate. And here we have one OR gate, so we will make it as NOR gate by adding one bubble. So this will be like this. At the output, this inverter will be as it is. This is given to another OR gate, so that will convert to NOR gate. From here, one wire is coming from A, and that is directly going to final output. So here we have A, B, this is C, D. We can give some wire name, say E, F, G, H, and say I. Now next stage, we have to add an inverter in each of the line, say for A, B, F and I, because they have received one circle in the previous step, so that polarity of these lines remains unchanged. So line G received two circles, so no change is required. Say line G received two circles here. So what is the rule? If two circles means no change. We have to remember this. Two circle means no change. So let us put, wherever we have added bubbles, we will put inverter. So here we have two bubble, so there we will add the inverter. Say A and B will have inverters. So this is A, this is B. Both of them are connected with the bubbled AND gate. Now output of this is connected to next AND gate where a bubble is added. So here also we'll add one inverter. Now with inverter, this will go to this diode. Here also we have added one bubble, but due to two bubbles in this line, we will not make any change. So this will be connected as it is to this one C and D. So here also, here we have this OR gate. This AND gate is connected to next NOR gate. Already one inverter is there, this H, that will connect to the final NOR gate. So after NOR gate, we have added one bubble. So here also we have to add one inverter. Now from A line, we are getting one line here like this. Now what we have to do, we have to replace all AND gates and NOT gates. So we'll add all these AND gates and NOT gates using NOR gates only. So this circuit we can draw by using only NOR gates. First we have one inverter here with A. So this one will have, this is A. This inverter is converted to NOR gate. Then C. Then B is also converted, so that we'll give as B bar. This inverter in line B has been removed, assuming B bar is available. So here we will remove it, and this one will connect to next NOR gate. Then C and D, they are already connected to one NOR gate. Output of this one is connected with one inverter, so for this also we require one NOR gate. So this one also will convert as NOR gate. So this output and this output, say from A line and from this line we will attach to one NOR gate. Now this is connected to next inverter, that will also converted into NOR gate. These will be given input along with this line A to next NOR gate. So next OR gate. After that we have one more NOT gate connected, so that also we have to show here. So this one will be connected with here we will connect these two lines as two lines to next NOR gate. So now this is the conversion for this same circuit. Now let us discuss the universal gates. There are two universal gates we use in this subject, say NAND and NOR. NAND and NOR gates are considered as universal gates. So these gates are called as universal gates because these gates can be used to construct all other gates by using only NAND and NOR gates. So we can see, suppose we can realize various gates using this NAND and NOR gates. Suppose say we can realize the realization of AND function using only NAND gates. So its formula we can get AB is AND gate. So here we can use AB double bar equal to AB bar whole bar. So by using NAND gate we can make AND gate as, say, A and B are two inputs given to one NAND gate. Its output will be given to second NAND gate. So it will be AB double bar, that is nothing but AB. So this is realization of AND using NAND only. Then we can also see the realization of, say, OR gate. We will see OR gate using NAND gate. So OR gate gives addition, say A plus B is equal to, say, A plus B double bar, or we can say A bar dot B bar whole bar. So its logic circuit we can realize as, they will give input A to both the inputs of NAND gate. So output will be, say, A bar. Will give input B commonly to both inputs of NAND gate. Will get B bar, and these outputs will give to another NAND gate. So that will be A bar, B bar, whole bar, that is nothing but A plus B. Similarly we can realize NOT gate using NAND gate. Say we can realize NOT gate using NAND gate, so that we can get as A bar is equal to A dot A whole bar. They will give input A combinedly to NAND gate, so we'll get A bar equal to A bar. Similarly we can realize AND using NOT. So what we can do, we have to get AND AB, that is nothing but AB double bar, that is nothing but A bar plus B bar whole bar. So this one we can connect with NOR gates, as they will give input A common to both the inputs of NOR gate, so here we will get A bar. Similarly we will connect B commonly to NOR gate, here we will get P bar, and its output we can connect to next NOR gate, so here we will get A bar plus B bar whole bar is equal to AB. Now next we can see so we can say realize NOR gate for next type of gate, say realization of NOR OR gate using NOR. So OR logic is like A plus B, it will be equal to A plus B double bar, that is equal to A plus B whole bar. This can be implemented as they will give A and B inputs to single NOR, its output will become A plus B bar. So this one combinedly will give to next NOR gate, so its output will become A plus B double bar, that is nothing but A plus B. Now we can also realize NOT using NOR. So simply what we have to do, we will simply take single input A, we will give it combinedly to the NOR gate, so it will be equal to A plus A whole bar is equal to A bar. So this is about the universal gates. So with this we will stop this session here. See you in the next session. Till then, have a good day. Thank you.